dovrebbe arrivarti. Controllo, posto.
morning, ladies and gentlemen. Please take a seat. I would like to very warmly welcome to the last day of this 75th International Astronautical Congress, and actually to the last program highlight of our plenary program, which is the late-breaking news sessions. And this late-breaking news session will focus on the historic inaugural flight of Ariane 6, which, as you may all know, took place on 9th of July this year. And this remarkable achievement marks a major milestone of European space exploration, with a brand new rocket launching from a new pad. Despite inherent challenges, Ariane 6 succeeded on its first attempt, showcasing European engineering excellence. In these sessions, experts will explore how the space team Europe, including ESA, CNES, Ariane Group, Ariane Space, achieved this success, the challenges they had to overcome, and the innovation that paved the way for Ariane 6 to launch Europe into a new era of space exploration. You will have the opportunity to ask questions to our distinguished speakers using our Slido system, which you are for sure already very familiar with. Please use the hashtag IAC 2024, register, and then please submit your questions. And it is now my distinct pleasure and honor to introduce and to welcome on stage the moderator of this late-breaking news session, Aline Decadi, from the European Space Agency. Please give her a warm round of applause. Thank you.
Hello, everybody. Welcome for the late-breaking news this morning. I would like to introduce you the three experts that will talk about this today. As you said, you will have the app. Please ask your questions, and we will answer it at the end of the presentations. So I would like to welcome on stage Piero Resta from the European Space Agency, Ariane 6 Program Manager, François Deneux, Ariane 6 Program Manager at launcher level for Ariane Group, and Olivier Bunier, CNES, the Ariane 6 Project Manager for the launch-based structures and means. Sir, the floor is yours.
So finally came the day in which we shall speak about the first mission of Ariane 6. That I said before I had, it has been a great success because it corresponded to the way, to the spirit, and to the methodology that we have applied to the development, that is right first time. Right first time has inspired all the development process since the beginning. We will see some detail about it. And right first time, thank you very much. And it has been, a right first time has been the result of the first flight. So, just a short recall of what is the fleet of European launchers. Until mid-2023, we had an heavy lift launcher on the launch pad. It is Ariane 5 that has completed this brilliant career with extraordinary launches like JUICE and especially James Webb Space Telescope. And then it is to be replaced by Ariane 6, especially the heavy configuration of Ariane 6 that is with 4 boosters, what we call the Ariane 64, and the same for the phase-out of Soyuz that was accelerated by the famous event in East Europe, and this to be replaced by the light version of Ariane 6 that is called Ariane 62, where 2 is the number of the booster that are integrated in the launcher configuration. The Ariane 6 program was born in 2014, at the ministerial 2014, and it was set up, I shall say, quite quickly, because there was a sudden change of direction with the abandonment of Ariane 5ME and the switch directly to an Ariane 6 that would have been using the greatest possible heritage from Ariane 5, so without major changes in the lower stage propulsion architecture, but with a lot of changes in the industrialization chain, the manufacturing chain, and with the innovation of reusable, reignitable, upper stage based on the motor Vinci. The Ariane 6 program could be implemented thanks to the cooperation of many countries of Europe. Switch too early. Back. Many countries of Europe that have participated and participate to the development of Ariane 6 and will be the consortium that will produce the launcher under the mastering of our launcher system Prime Ariane Group. And here is the day. Here it is the day. You can recognize some faces that are here in the room today. Someone is not there, like Karim, that is represented, the director of CNES Space Transportation, represented here by Olivier Bougnier. What were the role of ESA? The role of ESA was threefold, basically. The program management, so the classical role of ESA and the relationship with the participating states and delegation. The procuring entity, individually of the launcher system and the ground segment, what we call the launch base, and the launch system architect, that is the function that I have had the honor to lead. The launch system architect was integrating the two segments, ground and flight, performing the system verification and checking the compliance to the high-level requirements of Ariane 6.
Yes. CNES, you will see on this slide that CNES has had several tasks and several responsibilities in the development of Ariane 6. One of them is the classical, I would say, French Guiana Spaceport and Launch Range Authority, but also the Safety and Space Law Compliance Authority. This responsibility on space law and safety is independent from the developments and from the program. And so my task as Ariane 6 program manager in CNES was to bring a consistent behavior, consistent view and actions on CNES on their several tasks. So this was the first responsibility.
And Ariane Group, we are the prime contractor for the launcher system. For the launcher system, as you know it, this is not only the launcher, this is also the complete production system, including the industrialization of the complete chain. And of course, this is not only Ariane Group who delivers the launcher. And by the way, at the inaugural flight, we have delivered the launcher at 0 to ESA, because ESA was also the launch operator. But this is with our partners that we deliver the launcher, and the launcher system, the production system is also within the factories of our partners. So we have 15 major partners, and we have more than 300 suppliers on this program all over Europe, since we have 13 countries involved in the program as presented by Piero.
So CNES developed the ground segment, the ELA4 that we see behind this picture, and we will see several pictures later on. And the adaptation of the launch range. The CSG, the Guyana Space Center, was adapted for Soyuz, Vega, and Ariane 5, and needed some adaptation to be adapted to Ariane 6. So this new launch pad was built from scratch. It was not a refurbishment of an old one, and worked perfectly well in July.
And so for also the inaugural flight, so we were the operations conductor, integrated in, with CNES in a joint team. And it was just after the combined test, and I can say, Olivier, that during the combined test, it was the reverse. CNES was the conductor, Ariane Group was the deputy, and so we organized this so that we have a very mature system at the day of the inaugural flight. And CNES was developed in the launch complex as made possible to Ariane Group to operate the launcher for the first flight and after for the exploitation.
Yes, and indeed it is in 4 steps that Ariane Group take the exploitation of the launch pad. So in the first step, CNES developed the launch pad and qualify it alone, without a launcher. The second step, which was really important for the right first time for the first campaign, was what we call the combined test, which means that with a almost real launcher, it is a real launcher without the real boosters, were tested in the launch pad, all the chronology, the nominal and degraded cases. And it was performed under the responsibility of CNES with the integration of Ariane Group teams. And on inaugural flight, as said by François, we switch responsibility of Ariane Group with the support of CNES team. And from the next launch, which is a commercial launch, it will be operated by Ariane Group.
So this is the organization that also corresponds to the principle of the right first time, because, as explained by François and Olivier, the roles of CNES and Ariane Group were set in a way to secure the quickest path to the inaugural flight, but also to secure that the inaugural flight is the first of a series of successful flight in exploitation, with the exchange of role between CNES and Ariane Group. CNES that led the role of the test conductor under ESA responsibility for the combined test, and then progressively shift the role of operation manager to Ariane Group, because they have to implement this role for the exploitation campaigns. So another answer to the question, how did we succeed, is the way we have planned the development and verification process, joined very tightly with the decision process that is led at management level. We introduced some important modification in 2022 that have led to really streamline, and I use this word because indeed the management routine was also called a streamlined management team, and it was based on a set of instances of problem analysis, escalating, and decision that has allowed to take decision as quick as possible. And sometimes the decisions were not that easy, as you can imagine. So we had joined the 3 teams with the design authorities, ESA, as launch system architect in groups called end-to-end engineering team. Then we had a coordination at the level of chief engineers of ESA, Ariane Group, and CNES. And then we had this management team called SMT, where the program management of ESA, Ariane Group, and CNES were sitting, with the participation of Arianespace that has to take the lead for the exploitation. And at the end of the escalation, we find the task force, the Ariane task force, that is at director level. It was an entity to which we brought all the status, and we received recommendations, and it is composed by Joseph Aschbacher, our ESA Director General, the CEO of Ariane Group, Martin Sion, and the President of CNES, Philippe Baptiste. The development program has been set out so as to eliminate the risk as early as possible. We started with the idea that we would have tested everything with the real launch base and the real launcher already, with the launch base already qualified, and the real launcher in the classical combined test campaign. We decided already in 2017 to introduce preliminary test at system level called early combined test. And already in the development logic, we will listen from Francois the explanation of the importance of the upper stage firing test performed in Lamp 1000. We designed and built with DLR colleagues a new test bench called the P5.2 in Lamp 1000, and there the complexity and the very important performance of the upper stage were tested in a very deep way. Last, we performed on the launch pad, so the launch pad was for 1 day converted in a test bench. We performed a long firing test of the lower stage of Ariane 6. And indeed, this has led to the fact that the last leg of the development, the last part of the development, was incredibly efficient. We performed all the combined tests in defining the timeline, and the launch on the 9th of July, as announced many weeks before, some months before, it was performed on time. Aside that, the qualification process with the classical ESA approach and the classical Ariane in general approach to the reviews. You see the effect, we visualize the effect of how we performed this qualification review that we call the smart process qualification review. And it was a review that was performed integrated between ESA and Ariane Group on the launch system and launcher system together in 2 big steps, one in April and the other in June 2024. And this was the last element that has played a very important role in the achievement of the inaugural flight.
Maybe we can say just before, maybe for the first time of development, at least in Europe, the qualification of the launcher and the launch base was not on the critical path, meaning that we were successful in anticipating the qualification of all these elements in 2 steps, as said, in July 23 and after in April 24. With a very condensed period of time with all the experts in Europe working with the project team so that we can go fast in qualifying the launcher. And so this is what we have called the conclave. Maybe this was the Roma influence, I don't know, Piero. But at least we are not in Roma here, but we are close to. And so this was quite new, the way we have implemented this way of working together. And it was a launch system and a launcher system jointly in parallel with the launch base. So we were successful in qualifying this very complex system at the same time. And I think that we were very happy to hear from the top management and the people having decades of experience, especially on Ariane 5 at the end of the qualification of the launcher and launch system, telling us the quality that you have achieved is the best we have ever seen on the development. And so, at the same time, we were successful in putting the schedule under control. We have delivered a qualification documentation, which was very good also. And the success of the flight is also the result of this, because it's not enough to have a launcher on the launch pad. You need, before the flight, to demonstrate that everything is under control, that all your models are okay, and that you have tested, and you have demonstrated on the paper that you can fly.
Yes, and I want to use the opportunity in front of you to very warmly thank all the teams, the hundreds of teams that performed these activities with very huge engagement, very huge effort during months to deliver the stages, to perform the test, to deliver the documentation. And it was really, really a momentum of work, of common work. And so really warmly thanks to the team. Some of you are here, some can hear us outside this room, but really warm thanks to all of you. So no, it was not this one. So a scheme of the operational concept of Ariane 6. Maybe we will not take too much time on this, but some words. So as on Ariane 5, a major part of Ariane 6 is built in mainland Europe. The boosters are filled in Guyana, in the Propergol facilities in Guyana. The one important thing to have in mind is that all these steps that are the nominal steps in Ariane 6 launch campaign has been tested in nominal and degraded cases during the combined test. And so, step by step, we qualified, verified, and validate these different steps until Ariane 6 is built inside the mobile gantry. Mobile gantry, as you see on the picture, has been removed only some hours before the launch, but during the several days before the launch, we work inside the mobile gantry. This is a very huge building, more than 100 meters high, and several thousands of tons of this huge structure that is mobile and leave the floor for the liftoff, the day of the liftoff. Maybe on this slide, it's okay, colleagues. Go. So the launch pad and the launch system element, as I said, there is this huge mobile gantry. On the left side, you have a picture of the cryogenic fueling arms. So heavy arms allowing to fill and empty, if needed, the upper stage with liquid oxygen and liquid hydrogen. Below, you find on the right side, below of this picture, you see the assembly building, the lower stage and upper stage, lower module and upper module are assembled in this horizontally in this building. They are transported to the launch pad. We will see picture right after to the launch pad on some dollies. There are some hundreds meters from this assembly building to the launch pad. And the verticalization is performed on the launch zone. So all this has been developed by CNES and its suppliers and industrialists.
Okay, so the Ariane, you know that the configuration of Ariane has been made so that we have as much as possible flexibility during the exploitation phase. And this is the reason why we have this two version with 2 boosters or with 4 boosters, so that we can adjust the performance of the launcher, and so of course the cost, the price of the launch to the need of the customer, and so that we can also address more easily at the same time the commercial market, but also of course the institutional market for the European missions especially. And something which was also invented, I would say, on Ariane 6 is to develop a common booster between Ariane 6 and Vega, the evolution of Vega, the Vega C. And so the booster of one booster of Ariane 6 is also the first stage of Vega. And Ariane Group, we have developed this booster with Avio jointly together, and it has flown 2 times on Vega and now 2 times on Ariane 6. After the design of the launcher is something that which is quite common because it's using some of the technologies of Ariane 5. So we have the 2 solid rocket booster or 4 solid rocket booster, and the purpose of which is to take off and to provide the thrust at the beginning of the flight. After we have 7 minutes of flight with the main stage, the LLPM, what we call the LLPM, but this is the main stage of Ariane 6, and after we have the upper stage and the upper part. As said before, the main stage and the upper stage, we are using liquid oxygen and liquid hydrogen, so the most powerful propellant that we can use in our domain, and this is of course an heritage of Ariane 6, Ariane 5. What is new and very new is the new engine that we are using on the upper stage, the Vinci, and the capability of Vinci is very different vis-à-vis the HM7 of Ariane 5 because this is a reignitable engine. But you know, this is not enough to have a reignitable engine. You need to develop a reignitable stage, and this is a bit more complex because this is not just have the ignition of the engine that you need to make sure. This is the stage itself that we have to control, and especially all the fluid management for the stage is very important. And at the beginning of a bit after the beginning of the development, we have seen that the market was evolving very rapidly, the constellations were there, the missions to be addressed by Ariane 6 has increased drastically, and we had to make a choice: either we stay with the initial configuration or we change the configuration to adapt to the market. Guess what? We have adapted the launcher to the market. And so this upper stage on Ariane 6 is not an upper stage, this is an upper and orbital stage, meaning that we have the capability to go into orbit, to maneuver, to change the orbital plan, to ignite the engine, to reignite the engine, and for that we have added to the Vinci a secondary propulsion system that we call APU. APU is... The name means auxiliary power unit, so you see that at the beginning it was just to provide some power so that we can reignite the engine. And years after, it becomes a completely propulsion system. So we have on the upper stage, on the orbital stage, 2 propulsion systems using the same propellant, fed from the same tanks, and this is a closed loop because the APU is also used for the pressurization of the tanks. And so this is what makes Ariane 6 beautiful, very performant and very flexible. This is also, from a program manager point of view, how you make your program a bit more complex in the middle of the development. But we were successful, and now we know that we have developed something which is very powerful and very promising for the customers. And we will see at the end that the backlog of Ariane 6 is really well booked, and this is because we can address all these missions thanks to this very innovative upper stage. Okay, so as I said before, this is the typical illustration of what we can do with Ariane 6. Very classical missions, as we did a lot with Ariane 5. especially the GTO with single and dual launch. The heavy LEO missions also, the large science satellites, which was also the capability of Ariane 5. We can recall, for instance, James Webb launch 2 years ago by Ariane 5. But what is a bit new with an illustration of what the capability offered by Ariane 6, this is the capability to launch the Galileo constellation. It was true for Ariane 5, but with a different upper stage. Here we do it with the same upper stage. And as I said before, the capability to launch LEO constellations on different orbit is now a capability that we offer with Ariane 6. And for those who know quite well the backlog of our missions, this is a very important segment of the commercial market of Ariane 6.
And François, we may just on this slide remind also the extreme care that we had since the beginning of Ariane 6 on the conditions that we offer to the pilots that will be on board, offering a very important volume under the fairing. We have the fairing in 2 different sizes. And with respect to Ariane 5, we had the innovation that the payload that is in case of the dual launch, the payload in the upper position, the payload in the lower position, have almost the very same environmental conditions, and we shall not longer distinguish between a primary and a secondary payload. And the fact that we are introducing also new auxiliary payload services through the initiative that is called Multi-Launch Service, MLS, that will be soon on board the launcher, and they will offer some very interesting opportunity for payload of a smaller dimension, 500 kilograms, 1 ton. And last, it is not in the picture, we are also developing for Ariane 6 an orbital transfer vehicle associated with the launcher to perform classical services like last miles, change of some orbital parameters, and this will allow also the definition of new kind of ride share. Ariane 6 is very modern.
Okay. Now we will move to the inaugural flight. But before being able to assemble a launcher in Kourou and to fly, you need to produce the launcher. And something also which was new on Ariane 6 is the development of the production segment, much in advance in the development. We have started to develop the factory in 2017 and 2018. Not only within Ariane Group, but also all over Europe with our partners. And so the launcher that we have tested in Kourou, the launcher that we have tested in Lampol 1000 before the inaugural flight have been manufactured, tested and delivered by the production factory, by the exploitation factories. And so it was a way for us to, well in advance, to progress on the industrialization and to have the possibility from the beginning to engage an important ramp up for the production, and you will see at the end of the production that this is where we are. So before going to Kourou, we had to manufacture the different elements of integration to integrate these different elements in our factories in Europe. So mainly in Italy for the booster structure, in Bordeaux for the manufacturing of the booster nozzle and also the skirts of the booster. But also the integration factory in Bremen for the upper and the orbital stage, and in Les Mureaux for the integration of the main stage. Of course, we had also factories in Spain for the composite structure, in Germany for the metallic structure, also in the Netherlands for the huge rear part of the launcher, which is manufactured in the Netherlands, and also in Belgium, for instance, for the actuators, or in Switzerland for the fairing. All of these have been developed with adapted or new factories. And of course, we have the same in Kourou for the solid rocket booster, because we don't travel with 140 tons of propellant across the Atlantic. So basically, we transfer the structure and we cast the propellant, and we integrate the stage, the booster, in Kourou, in also integrated factories. 2 points I would like to mention, because we talk a lot about hardware, and this is what is visible and what is easy to understand. But preparing a launch, this is not just producing hardware, this is also producing software. And so we have in Les Mureaux functional simulation and capability to develop and test intensively the software in very different conditions. And what was a bit new also on Ariane 6 is to have in Les Mureaux a replica of the launch base that we test with the hardware in an Iron Bird environment. And in Kourou, CNES, they have the replica of the launcher so that they can test also the launcher in front of the launch base when they develop their software and control bench. And something also I like very much is in such a program we have 10,000 of pieces. We have a lot of major structures and so on, and we have to transfer the launcher across the Atlantic. So the logistics is very, very important, and the transportation of massive and very volumic structure is also important. And so I'm very pleased also to introduce Canopy, which is a ship that we have developed to transport from continental Europe to Kourou, the main elements of the launcher. And you know that this ship is not just a transportation ship. We have developed it so that it's also a revolution in maritime transportation, because it was the first operational ship to use wings. And with these wings, we have the possibility first to reduce by 30% the cost of the propellant, because we use the wind, and the wind is free. And second, we have the possibility to adapt the speed of the transfer from continental Europe to Kourou. And so by doing that, we have the possibility also to accommodate the logistics to the cadence of the launcher and to adapt the cost to this.
And reducing the environmental footprint, by the way.
Yeah. So sorry, because you're right, of course. When you save propellant, fuel and cost, you save also some tons of CO2 for the planet. But initially, this was not our goal, and at the end, we have changed the world of the maritime transportation. We are very proud of it. And so after, once you are in Kourou, you have to continue the process of integration. So in our factories for the solid rocket booster, and here you see the different elements, how they are integrated and produced in Kourou. In Kourou, as said before, we have also a building for the assembly. This is a building that looks like very much to what we have in Les Mureaux. And this is not a surprise, because we have developed this with the same suppliers, same partners. By the way, we have changed drastically the way we integrate the launchers on Ariane 6, because now we integrate this horizontally. And we have used for this the knowledge of the aeronautics and the the people, Latécoère, who have developed this for us, they have also developed the horizontal line of assembly of the Airbus in Toulouse. And so when we say we reduce the cost of Ariane 6, this is not pure magic. And this is because we have changed our way of working. And this is because we have used the methods and the capability of the aeronautics to cut down the cost of integrating the launcher in our domain. So this was the integration in the factory in Kourou. And after, we have to move to the launch pad under the mobile gantry, as described by Olivier. So here, this is very spectacular because this is the moment we have to move from the horizontal position for the central core to the vertical one. Of course, we need to be vertical to take off. And so this was a very great moment, end of April, to see the launcher leaving the factories to integrate the launch pad. And in less than 4 days, we were capable to transfer the booster, to transfer the central core, to assemble it under the mobile gantry. We did that previously during the combined test, as explained by Olivier and Pierrot. I mean, of course, on the program, this was identified as a major risk. How we will do that, because this is the first time, this is totally different vis-à-vis Ariane 5, and in fact, it was probably what we did, and with a very strict respect of the schedule, very well prepared, no anomaly. It was like in a dream. It was, of course, very well anticipated. So I say that because sometimes you have in your risk register big topics and you don't know what will happen later on. But when you address these big topics properly, at the end, this is no more a risk. And so between end of April and beginning of May, we move from everything is in the factory to the launcher is on the launch pad, it is connected, and we can start the functional test under the mobile gantry.
And I would understand the comment of Olivier also on the overall cycle of integration and preparation to launch of the launcher on the launch pad, because we have made very important choices that make the launch complex of Ariane 6 extremely environmental friendly with respect to the previous launch pad that are in Kourou, thanks to choices that reduce at the minimum the use of energy. We have made the brave choice not to put climatization in the mobile gantry at the condition that we stay in the mobile gantry for a very few days. The target is 3 days. Of course, this was not the case for the first flight, but it is a target that is completely at reach for the next flights. And this has allowed not to climatize completely this huge cathedral that is the mobile gantry. And the other point that is extremely important is treatment of waters, because we use a lot of water during the chronology for different purposes. This water cannot be re-injected in the nature before to be treated, because it's plenty of pollutants, and those two elements are something about which we shall be quite proud. Coming back to the first flight was not only for the purpose of the qualification of Ariane 6, the inaugural flight, put into space real payloads. Of course, there are payloads with modest dimension, masses and sizes. They were assembled on the top of a structure that is there for qualification purposes. So that has a mass and a kind of moment of inertia that was precisely defined in order to match certain flight conditions, a certain important flight event, notably during the ballistic phase into orbit after the separation of the payloads. We have served a number of university research centers, also industry that wanted to make some in-orbit demonstration of their products. And this is a classical approach of ESA to offer inaugural flights, offering a launch possibility to people that otherwise could struggle in finding a cheap, low-price launch opportunity. Again, we did it, and we are very proud also about this.
I think we should.
And then finally the launch day. The launch day, if I'm not mistaken, we have a movie that can speak better than words. Yeah. This is what has happened on the 9th of July. I think that images speak better than anything else. The onboard cameras. Many of you have already watched the movie, the video live. It was retransmitted on the online platforms.
Pilotage calme, trajectoire nominale. Séparation des ESR. Séparation de la coiffe. Séparation LLPM. Allumage du moteur Vinci.
The mission, what we call the commercial phase of the mission. Was completed with the payload separation and injection to orbit. I will not read every figure, but the environmental level that we have measured in flight are very, very, very much comfortable and satisfactory for us. The propulsion curves, the propulsion data were perfectly fitting the previsions. And the separation phases, the transient phases of the flight, the maximum dynamic pressure, separation, etc., were always exactly fitting the forecast and well inside the safe margins of qualifications. The most important factor, but this I would like François to explain the importance of the reignition of the Vinci.
It was very important to demonstrate that we have this capability. So we have tested this a lot on ground, but you know that on ground it's a bit difficult to simulate microgravity, especially when you want to ignite an engine. And so we knew that it was theoretically possible. Everything was put under control, but this is only in flight and in orbit that you can test. As I said before, not only that the engine itself is reignitable, but that the stage is able to perform all the maneuvers so that you can prepare the propellant and the feeding system to be exactly as it is needed to reignite an engine. And this was the challenge of this first test, first flight. And of course, we were very happy to see Vinci running a second time during the maiden flight. And at the end, we were also very happy to see that we have on Ariane 6 an accuracy which is comparable to Ariane 5, even a bit better. But that means that what was the beauty of Ariane 5, you know that, for instance, on the James Webb telescope, we put the telescope into a very perfect orbit, that we have the same capability, the same features on Ariane 6, and that we can guarantee to our customer that we will put their satellites, their missions into the right orbit with a very good accuracy.
Everybody knows that this means having maximized the lifetime of the spacecraft that is released to orbit. In the little movie in the center, we see something captured by the camera installed on board a spacecraft that has been developed by the ISA League of Junior Professionals. And this is another very nice fact to record. And then, Olivier, I leave you.
So now, very quickly, because I think time is running, we will not have so much time for question and answer, but I think you can understand that for me, for us, for all the teams, this 9th of July was really a major achievement, really intense. To say about me, I was sincerely confident on the success of the Ariane 6 flight until 30 minutes before the H0. And then I begin to think, but what if, and so on, and have we made all the maximum, and so on. And then after liftoff, we had step by step all the success of the flight, and it was really a great achievement for everybody in Kourou, everybody in Europe, in mainland Europe, as you can see on all these pictures.
And so, of course, the inaugural flight was a huge challenge in the development, but this is definitely not the end of the story. This is just the beginning, and what we have in front of us is to serve our customers. And so we have 30 missions in the backlog of Arianespace. By the way, I'm presenting this on behalf of Arianespace because Caroline Arnaud, who is the Ariane director, cannot be with us today. And so now what we have in front of us, this is the second challenge, which is to enter into the exploitation of this launcher for probably many decades, with some improvement along this part of the history of Ariane 6. But the ramp-up is a challenge, sometimes more difficult to achieve compared to the development and the inaugural flight. Should not say that as a program manager for the development, but this is true. The ramp-up is very, very important on Ariane 6. We have many customers waiting for us. Next year we intend to fly 5 times. So 1 the first year, 5 the second year. This is quite a ramp-up, and the year after we intend to have 8 to 10 launches a year. So very rapidly we have to ramp up. As I said before, this is not magic. This is because we have the production facility, we have the storage capacity also in Kourou, and this is not just producing the launcher, this is also launching the launcher, so the launch base capacity is also very important. And for that, as I said before, very soon in the process we have developed new factories with new production tools and processes so that we can launch 2 times more than Ariane 5, and we can very rapidly ramping up. I think this is the and this is what I said before. We have an order book, 30 missions, 2/3 for the commercial, because you know we have this contract with Kuiper, 1/3 for the institutional, but we continue to have very good discussions with a lot of future customers. And so after this inaugural flight, which was a success, and you can imagine how much it was important to have this success, we are now in this exploitation of Ariane 6 with a very brilliant future, because the customers, they are there, they want to fly on Ariane 6. We provide them a very reliable and high quality service. And this is also something which is very, very important in our business. So long life to Ariane 6. And just a word before we start thinking about the evolutions of Ariane 6, so that we can provide more performance. We can increase the flexibility of the missions. So here again, in terms of definition, this is not the end. We will continue to increment the definition of the launcher so that we can progressively serve our customers, institutional and commercial, with better performance, more flexibility for their missions. And this time it's it.
Thank you very much for this trip through the main step of the inaugural flight and the success. I have a few questions from the audience that I have collected here, so I will try to relay this to you. So we have around 5 minutes to discuss this topic. So first question is for François. You were talking about lessons learned and the secondary propulsion system that has been used and for reignition of the upper stage during the inaugural flight. After the successful second reboost, we also had a lessons learned about an anomaly on this, and the people would like to know how it has been treated. Is there an impact for the second next flight? And do you see something that prevents from giving the successful flight as we mentioned today?
Yes, thank you, Aline, for the question, and thank you for the people who asked this question. Yes, it's very important to explain that during this maiden flight, inaugural flight, we had two very different sequences. The first one is I would say, the Ariane standard. We go into orbit, we demonstrate the capability, we release the payload, and when we launch, we need to make sure that we have understood the complete design of the launcher is capable of doing that we have qualified this, that we have made all the tests for this and the computation for that. So this was the first sequence.
To be clear, with reignition of the upper stage.
With the reignition of the Vinci, we had two boosts of the Vinci, and so the reignition of the Vinci was part of this Ariane standard. We need to demonstrate it works, and it worked. And it was a full success, as said and presented by Piero. All the sequence, everything which is at risk, especially on a maiden flight, it was absolutely perfect on Ariane 6. And after, we had this second phase of the inaugural flight, and it was dedicated to test in flight what we cannot test on ground. So it was like a test in flight compared to the test that we have on ground, because as I said before, the behavior of the fluid, the thermodynamic joined to this with the fluid, and the effect of the macro-G and so on. This is something you cannot test on ground. So you test on ground with gravity and thermodynamic conditions, and after you translate with your computation to what could occur in flight. But of course, what you put in your model is what you know. what we wanted to test is what we don't know. And of course, and this second part was dedicated to this. And so we have made the second part of the flight, which was very risky. We tested the systems to the limit to have as much as possible data. And yes, we had an issue with an anomaly with the reignition of the APU. Not because of the APU, but because of the thermodynamic conditions. We have put so many measurements on the launcher, including cameras and so on, that we have clearly identified the reason why this system was not able to reignite. And by the way, we reignited, but we had the control that makes the software, okay, I'm not sure it will work perfectly, so I don't want to have a debris into orbit, so I stopped the engine. By the way, we could have continued and so on, but this is a second story. And so this, we have understood this very, very well because we had the data. We have corrected the sequence, especially a correction of the software. And so for the next flight, everything now is under control for the first commercial flight. And in addition to this, for an inaugural flight, you can imagine that we go through a gigabit of data to look at if everything is as expected, and sometimes this is within the limits, but you would like to understand why this is not exactly what you have predicted. You go through, you look at it very carefully, you adapt your model, you look at it, and this is where we are. But everything which is needed to fly a second time is now totally understood and under control. And we are preparing this with the next customer, explaining this, okay, this is the first flight, this is what we have modified, and this is why we believe we can fly with you.
Thank you, François. Olivier, can you just add some information about how the people managed to operate the ground software at CNES and then relay all this knowledge to the Ariane Group team for the first launch, how it worked?
Yes. So as mentioned before, the ground software and the ground control and command system was developed by CNES, but from the beginning of the development, it was performed, the control bench and the associated ground software was developed in a common team with people from under leadership of CNES, but with people from Ariane Group integrated in the team. Integrated in a team, not only to answer to your question, to prefigure this transfer of exploitation, but also to be sure, because it's something that is really integrated, the need of the launcher, this control and command system need to answer to the need of the launcher. So it has been, and there are also, on the other side, if we have some specificities of the ground control and command, there may be an impact on the launcher. And these integrated teams, one for the control bench and one for the software on the ground software, was a common team, Ariane Group CNES from the beginning. Then the other part of the answer is how I presented the progressive implication of Ariane Group in the command test in the first campaign, and then now in the second campaign. And by the way, in the second campaign, we will still CNES be present. Less present, but still be present to help, if needed, Ariane Group to take these activities.
Thank you, Olivier. It's very major, critical steps to be sure that we have these softwares like very major for the next launch. And just to finish with you, Piero, could you tell us a little bit more about the next developments and technology that will be used for reusability of the launcher?
Reusability is, of course, a sort of mantra. Everybody wants launches that are reusable, and I think we have fully understood that to the point that ESA started since quite some time developments in the technological and the preparation of future. with project like Prometheus, Themis, and also some other that looks rather than the smaller size of launchers in the Vega world, to introduce us very soon reusable stages in the architecture. We don't know if we'll still be called Ariane 6, but this is not the point. But from a technological standpoint, we can say that ESA doesn't miss any activity and competence to go to the reusability. Now we have to decide the smartest ways to introduce that and to develop all the infrastructure that goes with reusability, because the life doesn't end with the landing of a stage on a barge or on a launch pad. We need to implement all the infrastructure for the refurbishment of the stage and preparation for the next time. And this is quite an heavy task that we have to introduce smartly and carefully.
So we are working on it, and it will be introduced in the next technology pillars of the launcher's development. Thank you very much, sirs. I would like to thank the audience for being there today. Enjoy the end of the IAC, and happy Friday. Thank you very much.
sí, no me acuerdo. Ladies and gentlemen, thank you so much for being here. The next session is about to start, so we would kindly ask you to please take a seat. Thank you very much. Please be ready because this session is going to be very exciting with the astronauts. So please take a seat. And we will start in just a couple of minutes. Thank you.
Ladies and gentlemen, let me ask you to take your seats as we would like to kick off this Global Networking Forum. It has already become tradition that on the last day of our International Astronautical Congresses, we are organizing a Global Networking Forum involving space flyers, astronauts, our traditional astronauts, GNF. And we are extremely pleased to also this year will be able to offer this to you. And I see so many people here who were coming here in also for the public day. So please enjoy this excellent lineup of space flyers. The title of this GNF I considered quite provocative, but I think that is stimulating the discussion. No risk, no fun, keeping human spaceflight safe. That's the title. And you will be able to ask your favorite questions by using our Slido system. You know it already, hashtag IAC 2024. Please submit your questions. And it is now my great pleasure to introduce somebody who has been instrumental in setting up the closest cooperation between the Federation and the Association of Space Explorers, which is an organization that brings together all the flyers. Reinhold Ewald, astronaut and president of the Association of Space Explorers and now also chair of the IAF Astronauts Committee, and it's my great pleasure to introduce him to you as your moderator for this session. Please give him a round of applause.
Thank you, Christian, for the very kind introduction. And he has almost, or he has certainly more than 50% of this idea, and I owe him every credit for this. So let's start with a session that would look into the obvious thing. If you come to a launch pad early in the morning, the rocket is already fueled, you will immediately have the feeling this is a risky maneuver that we are going to see soon. But the rocket and the gases streaming off the rocket, the kerosene, the hydrogen, the oxygen, that are only the visible signs of a risky maneuver about to begin. The spaceflight is still in a phase where you don't do it routinely. You always are aware that untested things may go wrong, even tested things may go wrong, that you have to anticipate, to improvise in space in order to make it safely home. And how you do this and what are the thoughts of the persons involved, because we are talking about human spaceflight today, that we want to clarify in this panel. And please make good use of the slido.com possibility to ask the questions to the podium. So I now would like to call to the podium the experts of today's panel, all with their own experience. And the first and I think most prominent alone from the body height of this Congress is Luca Parmitano. Luca, take a seat. The next in line is Tony Antonelli. And with a very special experience, Tuva from Turkey. We are a 3G Congress, so we try to balance at least a little bit. It's always a deficit in spaceflight to balance the gender representation. So it's a great pleasure to have Antea Comellini on the stage. And what would such a panel be without Aki Yoshide? Last but not least, Eitan Stibbe. And you can see that we are generation-wise quite connected, Eitan. So I will introduce the speakers for the first round of questions. And the first question I will do from my seat here. The question is, yeah, thank you. The question is, I talked about the obvious risk, but there are hidden risks. What your personal, in your personal judgment, what was the moment where you were most scared? Despite all the fun that we have preparing for a space flight, but where you really thought this is not in the plan and I should better get my thoughts together in order to make it home safely. So first, to answer that question would be, oops, yes, I get the answers. It's Luca Parmitano. Luca Parmitano from Italy. He graduated from the University of Naples. He's a test pilot with over 2,000 hours by now, I think, and 40 types of aircraft. Amazing.
Yeah.
A colonnello. That sounds in Italian much more nicer than in German. He has flown Expedition 36 and 37 on the Soyuz TMA, up and down, and the Expedition 60 and 61 on the Soyuz MS, so 2 vehicles. Maybe there's an impression. He has scored 366, almost 367 days in space. Huh? You could have delayed your landing a little bit.
I tried.
6 EVAs, that makes him the record holder of EVA still in...
Actually, in numbers, Thomas and I have the same number of EVAs.
Yeah.
Yeah, we have the same number.
Yes, with 33 hours outside, and now he's on ESA collateral duty. Luca, scary moment, let me guess.
Yeah, being up here, it's actually one of those moments. Right now I'm wondering, what the hell am I doing up here? So, I hope not to disappoint you guys, but I completely separate risk and fear. Those are two things that don't belong in the same bag for me. And I have a sense that, Tony, you would agree to that. If you are an operator, and by operator I mean somebody that picks a career in an operational field, be it on the field, be it in the air, as a test pilot, as a fighter pilot, risk is a component of our job. However, what is fear? That is the question, because your question is very specific. What is the scary moment? What is the moment where you are afraid? Scary moments, there are a lot. What are the moments where I'm afraid? That is a different question, because fear is a natural reaction. It's a functional, a physiological reaction to the unknown. So when we have to deal with something for which we are not prepared, we feel fear. And the physiological reaction is the sweat, the pulse accelerating, the adrenaline running through our body. But the main subject in all this sentence is the unknown. When we are small kids, and I saw some small kids out there, when we are small, when we are children, we are afraid of opening the door into a dark room and entering into the dark room. It's primordial, because we don't know what's in the dark room. We don't know if there is a hole, we don't know if there is an obstacle, we don't know if there's a monster, right? That fear prevents ourselves from putting in position of danger. We don't want to die, and our body tells us, you don't know what's out there, so don't go into the dark room. It's primordial. So, what's the easiest way to overcome that fear? It's to turn on the light. The moment you turn on the light, whatever is in that room appears. It could be an obstacle, it could be a hole, it could be a monster. However, together with the light and the darkness, fear disappears, because at that moment, once you have clear what's in the room, whether it's the obstacle, the hole, or the monster, now it's a different problem. It's no longer an unknown, it's an actual problem to solve. So if there's a hole, you have to go around it. If there's an obstacle, you have to jump. If there's a monster, you probably want to run away. But it's no longer fear, it's a problem to solve. So why do I say the risk and fear and my job are not in the same construct? It's not in the same Venn diagram. Because astronauts turn the light all the time. The light for us is always on. We study for our entire career, before, during, and after, to overcome the unknown. We study so that we know our systems. We study so that we know our capabilities. We study so that we know the capabilities of those that surround us. So it would have been very easy for me to say, oh, the scariest moment in my career was flying on the AMX and hitting, having a bird strike that almost destroyed my aircraft, or saying, when my spacesuit failed in the middle of my EVA. That's the easy answer. But I would be lying to you, because fear is not a component of those events. Risk is, but not fear. The reaction, the resolution of the problem, that is what we do in our training. We spend hundreds of hours training, hundreds of hours, months, years training to turn on that light into the dark room. And so for the kids out there, when you hear your parents and your teachers and everybody around you, the society telling you, study, read, travel, invest your time in knowledge, it's because we want you to go into life without fear. The more you know, the less you fear. Knowledge is the antidote to any fear, is the light that turns away the darkness.
Thank you. Time to introduce Dominic Anthony, called Tony Antonelli. Obviously, there is some Italian connection in your family, but he's from the USA, as you can see on his shoulder. He graduated from MIT and the University of Washington. He's a naval aviator, a test pilot with 3,200 hours, so and 41 types. So he beats you in this. Yeah. He has flown on STS-119 in 2009 and STS-132, both in ISS assembly missions, and he's now with Lockheed Martin, responsible for advanced programs of civil space. Tony, what is the risk component that you became aware?
So I have my scariest answer. I'll get to that, but I hadn't broken up risk and fear. So it's obvious I'm not as handsome as Luca, but y'all also didn't know I'm not near as good as answering questions either. So I'll be quick so we can hear more from Luca. But in the human spaceflight world, we talk about risks all the time, less so in your day-to-day. Though for me, the way I would separate risk is it's on one side of the scale, and the benefits of what you're trying to do are on the other side of the scale. And whether or not you're consciously making these trades as you go through your day, some folks smoke cigarettes. I don't know if anybody's told you. Some of the docs have said that's not so good, but you're making that trade to say, hey, whatever you think the benefits are work better than the risks. I don't know how much here, I haven't noticed too much, but in the United States, folks drive their cars and text, which is trading their risk level, and I got to believe they think the benefits are worth it. I didn't get to vote, but I'm not sure I'm a fan. So that's how I separate risks. For fear, I'm not a big fan of heights, nor public speaking, but so the scariest part for me was at the launch pad when the elevator doors open and you have to walk out over this open steel grating to get to your space shuttle. So that was scary for me.
Yeah, and then it subsided with 2,000 tons of fuel underneath you.
Yeah, it transitions to like really fun, but I thought you were going to let me off the hook. I was done talking, but you don't get to pick your fears, right? You just show up and you're afraid. I'm going to go back and reflect on Luca's comments and go, maybe I should study more. Maybe I can control them better. But right now, often I show up and I'm either okay or I'm afraid. What I've learned through flying airplanes for the Navy, if anybody's landed an airplane on an aircraft carrier at night, that's terrifying. So I do know what like being really scared feels like. But I think you just show up and you're either afraid or you're not, and whether you're going to concentrate and do your job is completely within your control. So if you have fears today, but they're in your path to doing something that you want. Oh, by the way, I'm not the only one that's flown in space that's afraid of heights. So if any of you are afraid of heights, you can still fly in space.
That's good news. Next in line, Tuba Atasavet. He's from Turkey. He graduated from Beacon University and University of California in LA, San Francisco, Irvine. He's an engineer by profession, And he had a double chance this year. Amazing. He backed up Alper Gisarafci in the Axiom 3 mission and was almost next to the launch pad in this respect. But then he had a chance to go on the Virgin Galactic flight number 7 in June. It was 15 minutes of space experience. Tua, did you feel that the safety briefing that you get in such a high-flying vehicle, that it was sufficient for you to cope with whatever unknowns would be happening?
Well, if you're referring to the safety training we got during the flight week with Virgin Galactic, that was a surprising thing compared to the training we got at Johnson Space Center, which was 8 months long training, both theoretical training in terms of against certain emergencies that we can encounter on the station, ammonia leak, pressure leak, or fire, or medical emergencies. We would get theoretical training in the classroom, a comprehensive one. Then we would go into this beautiful place that we all love, called Building 9. That's where the mock-ups are, right? Whenever I went to that place, I felt like I was a kid in a candy store, that I could go inside of the mock-ups and pretend that I'm a spaceman, right? Just playing with those interfaces and learning. And we would go to those locations, to those mock-up facilities to train and carry out simulations, as Luca mentioned, hundreds of hours, right? We would do each and every emergency scenario. They would just throw certain stuff at us and watch us behave and carry out the procedure as expected. The Virgin Galactic side was completely different because their approach and their aim is quite different. Our entire training was just a week. It was slightly longer for me because I had payloads to fly, but the other private astronauts, they would just show up 4 days before launch and go through the entire thing in that 4 days, including every single thing that they need to learn about the systems, the emergency activities, and also, unlike Falcon 9, which has this escape abort system that would sort of carry you away from the risky aspects if something was to go wrong in the rocket, in the booster. If something was to happen in the Unity during our flight, we had parachutes on, and we would need to just jump out of the aircraft or the spacecraft to be able to survive. Given that operational scenario, the training we got, I don't know if I'm allowed to say that the amount of training we got from Virgin Galactic, it was a shock to me, right? The amount of emergency training that was given. Yeah, exactly, yeah, right, exactly. Just right before takeoff, just do this. Of course, they probably rely heavily on the pilots. That we had 2 pilots on board amongst 4 flyers. They, I'm guessing, heavily rely on the pilots to execute certain emergency activities. But what if one of the pilots are incapacitated, right? In my mentality, I should be as prepared as they are in the case of an emergency to act upon them. So it was a different approach from the perspective of 2 different spaceflight experiences and trainings that I got. But one thing that is maybe worth mentioning about fear and how to overcome fear, during our training, L-4, we had an aerobatic flight that we went on to both experience some heightened Gs, some high G maneuvers to get our bodies familiar, and also some reduced G maneuvers. We would do parabolas, and I had some payloads on me, so we wanted to test them out before flight. The aircraft that we flew on was called Extra 300. It's I think, a German-made aircraft, very fun one, and to maneuver and control. And it's an open canopy, right? You see everything around you. And the pilot of the craft, I'm up on the front, and Jamil Janjua, the Canadian astronaut of Virgin Galactic, we were together in the aircraft. We did our first parabola just just for me to feel, right? Because up until that point, I had not experienced the reduced gravity. So I didn't want to do anything with the payloads, but just to feel that reduced G. I don't call it the 0G or micro G because you're still in the atmosphere. Your engine is, even it's in the idle mode, it's still running, but it's 0.1 point Gs maybe, something like that. So you go up, 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 and all of a sudden you're falling down. You're falling down, and I could see, because of the canopy, the ground coming towards us. It's not too long with that aircraft, with the altitude that we were doing those maneuvers, 12 seconds, something like that, but you could actually see falling. But interestingly, that was one of the most serene moments of my life. The reason, of course, this reduced gravity has this sensation, that tranquil essence to it, but also I really trusted the guy sitting behind me, right? I knew that he had my back. I trusted him, just like I learned how to trust my crewmates from the AX3 training. So one of the ways in which that we beat fear in case of emergencies is trust our crewmates as well. And learning that was a huge, huge gift for me throughout this training. So, yeah.
And just a short question after that. How important was it during your actual suborbital flight to have payloads that you operated? Would you have done the same thing without payloads?
You mean take the flight without payloads? Oh yeah, yeah. I would take the flight tomorrow with no questions. But of course, carrying out research was important for our mission. As part of Galactic 7 mission, we had 7 different experiments, 3 of which I took to space, and I had to carry out certain operations on each and every one of them. This is all to grow the space science and space research in Turkey, so that those first steps that we took, the next generations, the next researchers are going to be imagining things that are more involved and evolved and more interesting in the years to come. So it was a very important and integral part of our entire mission.
Yeah, thank you. Antea Comellini, Italian. She graduated as a PhD from the Sub Aero in Toulouse, so your French is also excellent. In this, you're an engineer with Thales Alenia Space, and you have also stints with ESA as a space navigation engineer. And then ESA kind of recruited you as the reserve astronaut in 2022. And it's good to know that you will have upcoming training at IAC. It's a great place to start your astronaut career. When I remember putting an envelope at that time, no email, envelope with my application for the astronaut job into the mailbox, a couple of months later, Challenger exploded. And that brought me to the idea, do I still want to pursue this, what I did there? But in the end, I decided that we also learn from these kind of accidents. We have to learn. We are, as responsible people, we have to make good for the errors that are mistaken, and I continued. How, in your case, were you treating the thought of going on to something risky later in your astronaut career?
So for me, this one was a question that I asked myself really when the selection was announced, because at that time I've been studying and working in the space sector for quite a while. So I was more aware of what were the risks and the fact that actually we cannot control all of them. I mean, we can try to design for minimum risk, control the hazard, add failure tolerance, but there are still things that we cannot control. Like, for instance, one of the main drivers of the loss of crew probability is actually debris and micrometeorites. And those ones, we cannot control them, and we cannot reduce the probability about them. It's only going to increase, actually. So yes, I've been asking myself this question. Actually, the day they announced the selection, I really tried to picture myself on a rocket. So thinking, okay, went through all the selection and I went through the training. Do I really want to do this? And this question actually was also asked by each one of us, I think, also my colleagues, Carmen and the other, by the Director General. So when there was only 27 of us, so we were very close to being selected, and we could start feeling that things were getting real. And if you have the Director General of ESA looking into your eyes, and it looks like he's looking into your soul, not your eyes, when you're doing the astronaut selection, and he asks you, but are you ready to die in space? And even though I had been asking myself the question so many times, at that point it kind of became real to me. And I was like, I mean, I'm not ready, but I am accepting the risk. And why I'm accepting that? For me, it's always a matter of cost versus benefits. And first of all, I'm not risking just for the adrenaline. I'm taking controlled risk because the benefits are much higher. So I feel like I can contribute to the space program. I believe in the space program. I hope that one day I will be needed up there. And so I feel like I am ready to accept this kind of risk because I believe in what we are doing. And for me, that was the answer.
Thank you. And the honest answer. Turning to Akihiko-san. Akihiko Hoshide from Japan. He graduated from KU University and University of Houston. He's an engineer and started out in the NASDA, and then NASDA became JAXA, where he's still now. He has the experience of 3 flights and 3 vehicles. That's amazing. He delivered the Kibo second delivery flight with STS-124, and he was an engineer on Expedition 32-33 with its Soyuz TMA in 2012, and then became a crew member of the Crew 2 SpaceX flight for Expedition 65 and 66. He was a commander of Expedition 65 in 2021, and he continues with JAXA. Aki, after your first space flight, did you consider it valuable and responsible to continue, or were you sobered up?
So, yeah, great question. So, first flight, right after we landed at KSC on the runway, I immediately wanted to come back up to space. And I think we all share that same sensation. You were asking about scariest moments. So in hindsight, I think the scariest situation that we had was when we went out of attitude control on board the space station. Some of you may know we had an unexpected thruster firing on board the space station. That was during Expedition 65, and we started tumbling. We started going out of attitude. Usually, the station is flying, like that with respect to the ground, but apparently we were out of control. And of course, the alarm went off, and we started working the problem. The ground was working the problem with us, and we managed to resolve the situation. Later, after we came back to Earth, we saw an animation, what actually happened. And it was fast-forwarded. It was an animation, and it went like 540 degrees. So, you mentioned an acrobatic flight. Yeah, we did an acrobatic flight using the ISS. But were we scared at that moment? No, none of us were. And I think we were focused to resolve the situation. But at the same time, we knew that that kind of thing would happen. Again, it's about the risk, right? So we are mitigating the risk by, putting control so that it does not happen. And also, if it happens, we had procedures, we trained for it, we had ground controllers that are very skillful and knowledgeable about it. So all in all, that prepared us for that situation. So I think that's how we mitigated the risk. In hindsight, yes, we were tumbling, but you know, we managed.
So training and trust.
Yes, absolutely.
Yeah. Turning to Aiton. Aiton, excuse me, but the difference between all these friends here and you is you paid for your flight, and they got paid for their flights. So for you, it was not a career decision to buy a space flight or to go into the adventure of a space flight. It was a very consent with all your thoughts, a decision that you took. What made you overcome the obvious feeling of why do I need to do something risky? You could have bought a holiday somewhere. Yeah. What was your balance, your assessment of risk in this moment? Excuse me, I should introduce you. You're from Israel. You're an Air Force fighter pilot, and actually, I think as a special feature, also you originated two funds: for the Vital Capital Fund for investments in Africa, and the Ilan Ramon Foundation. Ilan Ramon perished in the STS-107 accident coming back from space. He was the first Israeli citizen in space. And your flight was the Axiom 1 flight back in 2022. So, yeah, a new feature. And you called your flight Rakia, which kind of is horizon, firmament, these these things that point us into the back away from Earth. Yeah, 17 days.
Thanks, Reinhold. Ilan Ramon was my friend. He was the first Israeli astronaut who flew 2003 and unfortunately did not come back because the Columbia crashed in 2003. I attended his launch. We stayed in good contact with his family. And the narrative of human spaceflight in Israel was tragedy. So it took years until the opportunity came because the Israeli Space Agency did not consider to send additional astronauts. When the opportunity came and SpaceX opened the opportunity for private astronauts to fly, I jumped on the first opportunity with a good friend, Garrett Reisman, who trained with Ilan, and hopped on that with the intention to change that narrative in Israel, that human space flight is inspiring, can change the future of scientists, children, and excite people, build their curiosity about the universe, about our being here. So about one of the frightening moments, first was to step into Building 4S in JSC. Just be aware because you see Bob and Doug walking towards you, and it's a really interesting building because it's only astronauts, and they're speaking about going to the moon, coming back. But then on our way back, we had about 16 hours in the Dragon circling Earth, and then they tell us, get in your suits, get in your seats. We're starting the deorbit process. About 420 kilometers above Australia, it takes about 20 minutes to reach Florida. So you start a few burns, the Dragon changes position, and it starts entering the atmosphere at 100 kilometers. And there you get the high G, about 4 or 5 G. You see flames in the window. And I knew that the Columbia crashed at 68 kilometers altitude, and I was looking through the window a little bit, but a lot at the altitude to see that we crossed that altitude safely. I had tears in my eyes, and not because I was afraid of my own life, but what I was doing, I experienced the tragedy of the Ramon family, and if I'm doing the right decision, it was a bit late, but to my family. So I want to say a word about trust because there were not so many accidents in space. very few. And during the training, you learn to trust the whole system. You see how many people work for your safety, and they care about you. When you're a fighter pilot, the enemy is against you. When you're an astronaut, the whole world is in your favor. We trained at NASA, with JAXA, at ESA, and everyone wants you to go there and succeed. And succeed because failure is easy. There's so many expectations for you as an astronaut on board that you won't succeed to complete the experiment, time will go by, didn't practice enough, and you're really afraid of that. But the whole meeting with all these facilities that take care that astronaut lives are saved, and I'll just give you a few examples about the launch. So the launch pad, you go up that elevator, and there's a cable, like an Omega cable with that can take you if there's something on top of the tower. If something happens, you can just slide down. If they moved away the arm, the bridge, then the capsule, the Dragon, can eject and go up to 8,000 feet and go back to be saved. And then along the whole east coast of the US and the Atlantic Ocean, there are crews waiting if something happens after launch and you have to abort and the capsule will land somewhere in the Atlantic. They're all planned. So that gives you a sort of a security feeling and trust in the whole system that is helping the astronauts succeed. Thank you.
Thank you. And now we are turning to the Slido questions. Don't forget to either vote for your favorite question to make it in the top, or put your own question. And we have an interesting question that obviously we have the experts here to give their assessment. We are seeing launches today where astronauts board the capsule before propellant fueling as opposed to the traditional procedure followed. What goes through the astronaut minds as tons of flammable propellant gets loaded underneath them? So the question is, what was the consideration to load the vehicle only after the crew has entered versus preparing it completely and then having the crew come? I remember my own flight on a Soyuz. We were approaching the launch pad, and a train was coming from the launch pad with a lot of empty wagons that had put all the kerosene and the oxygen into the tanks. So shuttle, I think, was fueled only after no. So then let's get the expert explaining.
So the shuttle was filled and reached stable replenish before the crew gets in. The Dragon's done it each way, especially with cargo. They would load it before, but the idea is the tanks are only so big. The colder you can get the fuel in the plant and get it into the vehicle while it's still cold, the more fuel and oxygen you can put in there, so the more capability you have. So they transitioned to that. They went through a bunch of reviews to make sure they could do it safely. But it's definitely the way to go if you want to take more stuff to space. But you don't know. You're just sitting there, right? You don't care, do you? What's the worst that could happen?
Right. So so Crew Dragon went the other way around, right? So like Tony said, you used to fuel it first, like Soyuz is the same. So you fuel it first, and then the crew members get in. But for Crew Dragon, because the temperature is lower for the fuel, and also you think about the thermal protection as well. So what we ended up doing was you enter, and then they fill up the fuel. So it's a reverse. Now, obviously, we had a huge discussion about that. They made sure that it was safe. We have controls in place, and you mentioned about the launch escape as well. So they make sure that the launch escape is armed prior to starting that process. So if something happens, we are able to punch off and save ourselves.
And here's one for the shuttle. While we fueled it ahead of time, right, we dropped the pressure down get as much as fuel in as we can. And about 1 minute and 45 seconds before launch, we pressurize the hydrogen tank. The external tank of the space shuttle shrinks like 3/4 of an inch as they're filling it, and then it makes that up plus another 3/4 of an inch. And this aluminum tank has a better max fraction than your beer can, right? The weight, full to empty, is better on an external fuel tank for the space shuttle. And I never thought my beer can was over-designed, right? But we decided to make it even thinner. And like you weren't even watching the hydrogen tank repress. So like if you wanted to be afraid of something, there was definitely something there to be afraid of, but
So
we weren't even watching.
fill it up, wipe the windscreen, huh? Luca?
Yeah, for the Soyuz up to this day, you can physically see that the Soyuz launcher is loaded with fuel before the crew arrives, because if you go on the internet and look at the lifting of the Soyuz spacecraft, it arrives on a train. It's actually pretty spectacular. It arrives on a train and is laying down, and then they lift it up and they hang it onto its launch system. And if you look at it, it's completely green. It's the typical military matted green from Russia. It's like iconic. And then if you look on the day of the launch, you see the astronauts arrive, crossing the pavement to the elevator, and you look at the rocket and it's white. And I guarantee you that nobody went overnight to paint the spacecraft white to make it pretty. It's ice that has been forming even in the heat of the Russian desert, because we're in Kazakhstan. In the summer it can be quite hot, and what happens is that the cryogenic fuel is so cold that whatever moisture in the air forms ice on the fuel cells. So it's a demonstration that it's being loaded with fuel, and it's still being loaded with fuel. You see the overpress tanks releasing some of the extra fuel that's being loaded, and then the astronauts go up the elevator, which I believe is still the same elevator that brought Yuri Gagarin up 50, 60 years ago. That would probably be scary if you thought about it.
Yeah, I was happy to leave it. Yeah.
Yeah, I never thought about it. It's a
Yeah.
really small elevator,
Yeah.
and probably very old, probably one cable. They probably didn't think about extra designs for safety about it. A couple of million people's of personnel inside, and it's just this little cable going up. Didn't think about it until now. See why we're not scared? Because we don't really have enough brain cells to think about those things.
Scared. Tuva,
but anyway, yeah, it's still loaded. It's loaded before we arrive.
your vehicle was what? Empty, loaded?
So it's a different system using a hybrid. It's a hybrid rocket engine. So your fuel is not kerosene. It's something else. It's a solid, and you are sort of pressurizing and pushing a liquid onto that solid fuel. And the time we entered into the vehicle, it was all loaded. The solid is already installed, right, overnight, and the liquid oxidizer, if you will, it was loaded as well. So, and there were quite a lot of people around that hybrid rocket engine. One of the supposed benefits of hybrid rocket engines, the first one they always claim is cheaper, and the second one is safer than specifically for the solid fuel engines. You have the oxidizer and fuel mixed together. They want to separate them so that it's safer. And there was a lot of people sort of operating and helping us out get inside and be ready and happy and healthy to fly up. So it was all loaded for our flight.
But they were not Boeing engines, were they? Just a joke. We have another question here which I want to answer myself.
Wait. Let Tuva finish his launch story, right? So he's got a very different launch experience than the rest of us. Are you getting your spaceship? It's fueled.
Yes. Yeah.
And now you're climbing up. Tell us about that.
So it's a different kind of profile, as Tony mentioned. It's an air launch system. We are traveling to 14 kilometers of altitude, approximately, underneath a carrier aircraft, which they call Eve. We are sitting on it, essentially, with our spacecraft. And at that altitude, if everything is right, we are released, and that release is a huge bang, right? It's, I guess, very similar to a stage separation. It's just huge bang, and you're falling for 1 second, and you guys might have felt that if you're going through just a tunnel down with a huge speed, you just, right, you just feel that kind of a...
And who doesn't like a bang and a drop?
Yeah.
I mean, no, you're in an airplane, all strapped in, bang, drop.
Exactly, yeah.
Everything is good. Awesome.
It feels amazing, yeah. For a split second, it feels amazing. And the moment that the rocket engine lights up, it just pushes you to your seats. That is the first shock. None of us in the cabin, we were expecting that much of power from that rocket engine. And yeah, we were in awe. The most spectacular aspect of our flight was no doubt the boost phase, exhilarating, super interesting. And yeah, by the time the rocket engine shuts off, you are already outside of the atmosphere. And the moment it shuts down, you're just floating peacefully. And that's, as opposed to this, I wouldn't say fearful, but adventurous and exhilarating experience, you just transition into the probably the most peaceful moment of your life. It was, yeah, that transition was also super interesting. So, yeah.
Let me add something about the excitement. Yeah. The fear on the launch pad after you train so long and you are 2 weeks in quarantine and finally get on the rocket. The main fear is that they scrub, that they cancel.
Yeah, there's an easy one to answer here. How do you poop without gravity? It's risky, yeah? We agree, yeah? So, the next one, being an astronaut means...
I thought you were going to answer that.
Being an astronaut means that you are part of a few select people, therefore you often are represented as a role model. How does this affect you in your daily life, and do you ever feel pressure getting to you? And that reminds me of a scene shortly before my flight, because 2 Soyuz cargo rockets crashed into a forest in Plesetsk, and there was a delegation from the German authorities that were doing my flight coming and say, Arnold, you know, if you are now want to bail out of this, we get you out for some financial reason, or we make something up so that you're not the coward who doesn't want to fly on that vehicle. And I was kind of calming them, saying, I'm fine, because I know that the human-rated Soyuz is a completely different vehicle, almost in production and in selection of the best components than the cargo vehicle, and indeed mine worked. So do you think that being put on this public notice does keep you from making a rational decision if you think the risk is too high? Who has been in the shuttle? You have been in the shuttle and in the line of command. So what was the threshold that you would not cross in terms of seeing an obvious risk and still going to launch?
Yeah, I think it's space flight's a giant team sport, right? And I worked on some shuttle propulsion teams, and so we were signing certification of flight readiness documents, which is much tougher job than actually getting on the space shuttle. I was surprised they asked you. I was never asked, hey, do you really want to do this? In fact, even the morning that we woke up before we flew on the space shuttle, like, you didn't have to be brave. Nobody was asking you to make any tough decisions. You just had to follow the crowd, and they all went to a spaceship and got in, so I just followed them along. But when you're in the meetings and reviewing the documentation of the shuttle propulsion elements that were just built, that's tough work. And I think then you're back to Luca's point. You got to do your work, and you got to do it as well as you can. But signing a document for somebody else to fly is a lot tougher than flying.
Yes, please.
I actually, if I can take a second on that, on the thought that just happened, I just thought of a moment where I really felt extremely uncomfortable with my capabilities and what I was doing. Probably one of the hardest moments as a flyer, and it had nothing to do with me. It was when I was the IV on the space station, getting ready to send out my crewmates outside for a spacewalk. And the way it works is that the EVs, the EV1 and EV2 going out, you can see the excitement in their eyes. And if you have been in that position, and I have been, you're thinking about the task, about the procedure. You're running it in your head, you're reviewing it in your mind, talking it with EV1 and EV2, they're talking it together. But the IV is doing everything else. They are setting up your suit, they're helping you inside the suit. It's a little bit the squire versus the knight. They're getting you ready to go out into the battle. They are closing your spacesuit, they are checking that everything is correct. They cannot do it. You are checking all the system outside, all their spacesuit connections, making sure that they're not leaking, that they are closely connected. And these are all manual tasks. The ground cannot verify them for you. The crew cannot verify them. You are the only one responsible to make sure that those spacesuits are safe. And even though it's not specifically because it's not your life on the line, but it's your crew's life on the line, letting them out into the unknown, into the void, is a lot harder than being the one going out and getting ready to go. And Aki, you have done this. Can you back it up for me? That is the most uncomfortable moment that you can. One of the most uncomfortable moments you can experience is when you're putting their lives in your hand.
Yeah, absolutely. I 100% agree with what Luca mentioned. So I had the privilege to do 4 spacewalks. I've never actually done IV on orbit. You've done it? Yeah. And I was so glad that it wasn't me, because there's a huge responsibility, you know. You're as an EV crew member, you're depending on the IV crew member.
You've done it, Tony.
Out.
I've only done the IV, so night and squire, night only, and squire only. And yeah, when even after you suit them up and just get them out, like the whole time they're outside, you're worrying that like you just want them to finish their work and get back in, and there's no relief like getting them back in and getting that airlock pressurized. But the whole time they're outside, I'm worried more about them than like even sending my kids off to do stuff. It's like
absolutely.
Yeah.
In my little moment of bragging, in my increment, expedition 60, 61, the second one, the second time I was in orbit, we performed 10 EVAs in the time that we were in orbit, 10, which meant that basically every couple of weeks we would be setting up to go outside. And because there are only 4 of us, 2 were going out and 2 were setting them up. Having the second set of eyes, checking that everything that you were doing was correct, was such a relief. And I think that we can add this little thought to the conversation. One thing that is really wonderful about taking a risk is the capability to share that responsibility with somebody else. That load can be crushing, but if you share it, it's a lot better. So I was very grateful as an IV, to either being backed up by somebody else or backing up someone before sending out my crewmates. And being the EV, I was really, really grateful for the work that my crews were doing to make sure that I was safe going out.
Yeah, vice versa, I remember the scene when they were congregating in front of the hatch and waited for you to come in with a helmet full of water. So all respect for Luca and Aki for their realization of safety in this responsible function.
Yeah. May I add one thing about the increasing risk of obviously walking in space, but of all the space adventures now, there are increasing amount of junk, debris in low Earth orbit. We learned that there are 130 million pieces of metal flying around Earth at 28,000 kilometers per hour, and damage was done to a Soyuz, taking it out of operations. A small piece of metal hit the robotic arm of the station. These are disastrous. We have to be aware of that as a space community, that we have to reduce the amount of debris around Earth because it's becoming dangerous. And last year there were 100,000 maneuvers of avoiding such debris or avoiding collision between different spacecrafts. So that is becoming much more difficult, and there's probably necessary to create laws about who cares how are things sent into space.
Yeah, thanks. We are running almost out of time, but I take the privilege to prolong a little bit. I hope I find your consent. We are not going to sing, by the way. We continue our conversation here. And there comes a fact to my mind. In former times, I think, when you were in NASA buildings, there was always a sign saying their lives relies on you. You, the engineers, you have to guarantee that you put the best piece of hardware on the launch pad, because these are the astronauts, the families, and they all count on you. Antea, spaceflight hardware is more expensive than normal routine hardware. Do you think that this is because you take extra measures also as an engineer to prepare spaceflight hardware in a special way, in a specially guaranteed way?
I mean, it's a set of those things. Not only spaceflight is expensive, also human spaceflight is expensive, also spaceflight of spacecraft, because the space environment is harsher, and there are conditions that are different than the one we have on Earth. And especially, it's not that easy to repair something that fails when it is in space. I mean, it has been done, like with the Space Hubble telescope, the Hubble telescope. Now we are trying to design spacecraft in order to be capable of doing that with robotic missions, but still you want really to validate and verify in depth and detail that your hardware is going to function as it is supposed to function. But actually, since we are not in space, it's even more difficult, because you have to try and find some condition that somehow is similar to what we are going to find in space. So all this process is very, very expensive and long. And when it applies to, when you put a human in the loop, it's even more difficult. First, because we design with different design rules in terms of failure tolerance, etc. And also because you have the human in the loop, which means you also have to add an additional layer of this verification and validation. So it results in expensive missions, but that are worth it.
Thank you. And I want to ask around another last question. It comes from Elias Malki. Thank you. What should be implemented as important safety feature but has not yet been done? A quick round. What you can imagine is a betterment of what we have today in terms of safety. Who wants to take it first? Okay, we are at the end of this. Luca.
Well, I don't know. I feel like when there is no answer, everybody looks at me. But one thing that I think we are working on, but we still need to really focus on and get really better at it, is to putting the human into the spacecraft and the spacesuit before making the spacecraft and the spacesuit. And what I mean by that is that ergonomics is a science today. We have been studying how we move and work in an environment. And yet, I believe that even the newest spacesuit and the ones for exploration, even though they made leaps versus what the Apollo astronauts used and what was available until now, they are incredibly, they're much, much better. They are getting better and better. They allow more mobility and less damage to the body. But I think there is always room for improvement. And what I would like to see is a little more imagination into how can we build these extravehicular suits so that they allow us to do more things. We are getting ready to do extensive exploration beyond low Earth orbit. We want to do traverses on the lunar surface. We want to do exploration. We want to perform science. And we are used to use we use our bodies in certain ways that are very efficient. And I'm looking forward to seeing equipment like spacesuit and spacecraft that are really ergonomic, so that we can get there, perform our tasks the way our body is meant to be used, and not only for certain sizes, but for all the participants of human space flight, meaning smaller bodies, longer bodies, taller people, mid people. It's something that we have to work on. And how is that connected to safety? Well, simple. A well-designed ergonomic environment avoids damage and is safer to use, safer to employ. So I think it's a very easy answer. However, I do understand, and please understand that this is extremely hard to implement. So it's just I'm just throwing there a spark of an idea for those students in here and those engineers in here that might have a chance to work on these systems. And sometimes a little spark is enough to ignite a fire of passion, and who knows, maybe they'll be able to come up with that idea that we still haven't had.
And my guess is the question was, what technological advancement or what material science advancement is going to make your individual spaceflight safer. But I'm going to take a different tact and remind us all that fortune favors the bold. So I think the very best thing we can do to be safe with humans flying in space is go much, much faster. And let's, as long as we're paying attention and learning from it, realize this technique won't make your individual flight safer. So, best of luck to you. But in general, for the future, if we do this more often at a much more increased pace, we pay attention, we're willing to make some mistakes and learn from them. But I think we'll be lucky more often than not, and we should go a lot faster.
Well, to touch upon what Eitan mentioned about having millions of small items, objects, traveling with immense speed in orbit. So we have already had multiple countries shooting down their own satellites just to show that they can. I think to also touch upon the theme of the IAC this year, the sustainability, we have to maintain the pristine environment of space so that beyond making it safe, to make it continue, right? So that we will be launching more and more people, we will be advancing our capabilities in the mid to long term. And to achieve that, we will not do some stupid stuff, and stuff is replaced by something that I'm not allowed to say here, stupid stuff, is to increase dialogue, increase collaboration amongst nations so that we will not do those stupid stuff and mess Earth orbit for the next generations. And the way to achieve that is, dialogue. Russians are not here today. And I think that's a huge mistake. We need to, one of the things during our training that helped our crew a lot was our NOLS training. It's a survival training, survival and leadership training that we took in the wilderness, right? After that, we had much better dialogue amongst each other. We trusted each other more. I really would love to see those types of wilderness trainings, going out camping with maybe heads of agencies. We can send them on such trips. Increase collaboration, increase interfacing amongst our nations, I think, is the way to keep spaceflight safe for the next generations to come. Thank you.
Thank you.
There, any ideas there on what is missing in terms of possible safety measures? AI?
The possibility to track very small pieces of debris in space, that would be really helpful because, you know, we're mentioning the collision avoidance maneuver of the ISS that are quite expensive also in terms of fuel, but we can do that with quite relatively big debris, but with smaller one that can still cause catastrophic failures. We cannot do that. So we are just, and I mean, it's not like a possibility. One day it's going to happen with a LEO station because there are so many of those pieces. And if we are better capable to estimate where they are and how they evolve, maybe we will be able to also prevent those type of failures.
Thank you. Aki?
So for low Earth orbit, I think we're doing what we need to do. Obviously, there's still room for improvement, but we talk about the materials, with the design, the backup system, operationally, you're thinking about what the next failure would be, procedure, training, and if something happens and you can't stay there, we can come home. We're that close, right? If we're going to go further to the moon, to Mars, we don't have that luxury. It's going to take a couple days to come back. So we need to be thinking about it, and we are thinking about that, how to cope with contingency situations. And so we need to kind of advance our thinking process and, think outside the box. It might be a new approach to things. One thing we're talking about, Japan's going to be developing a pressurized rover. But if you go out there and the rover gets stuck, what do? Right? Are you going to make the crew members walk back home? Or are you going to depend on a unpressurized vehicle? That kind of thing we're talking about. But we have to think about all the what ifs. And I think we're going to be at the next level of what ifs.
Ethan, your observations?
Well, I would put a doctor or a physician with every crew. Give the crew safety. They can trust someone, and the longer the missions will be to Moon, to Mars, it shifts from a physician to a psychotherapist because the challenges are immense.
Thank you. That wraps up our today's panel. Thank you. I wish you safe travels home. I think this is do not text, yeah, while driving. And we see each other next year in Sydney, I think. Yeah, done deal. Thank you for your patience and goodbye.
pozitività.
please welcome on stage Christian Feistinger, IAF Executive Director, who will be the moderator of this ceremony.
Thank you. Good afternoon. I am so pleased to welcome you to this IAC 2024 closing ceremony. Here we are all gathered in the beautiful city of Milan for this last day of this historic 75th International Astronautical Congress. Yeah. This last day today marks the end of an exceptional week, a week that has taken the Federation to new heights, a week to break all records. What happened this week is just unprecedented in the history of the IAF. Together, we have reached unbelievable dimensions with the technical program and with the number of delegates. You will hear about this in a few minutes. We all joined in Milan to engage in the most inspiring and timely discussions in the plenaries and the global networking fora. Through the IAF Awards, we celebrated our achievements and extraordinary talents that are the backbone of our community. However, the most significant success we have reached is the incredible enthusiasm shown by each and every one of you. Your passion and energy have truly created a collective spirit. We all together have a strong voice for space in the world, and the future of space is in your hands. I believe I speak for the entire Federation when I say how proud we are to have created this unique platform. Here we can all connect on neutral grounds in the spirit of cooperation and dialogue, transcend boundaries, and demonstrate unwavering unity of our space community. I'd like now to welcome on stage our IAF President, Clay Mowry. Please give him a warm applause.
Thank you, Christian. Dear colleagues, dear friends, dear space family, I am truly honored to be the president of this incredibly diverse federation. This past week has been truly exceptional for us, record-breaking week, and I've cherished every moment of being here with you guys. Now let's just recall a couple of the details here. As I mentioned at the opening ceremony, we have expected more than 11,000 people here, and we've broken that record, 11,200 delegates coming to this convention. Really incredible. And when I mention diversity, this is from 120 countries around the world. We really have the most diverse crowd. It is kind of the Space United Nations, as we like to say, so it's great to meet people from all around the world. We had 3,000 participants today on Public Day, 2,200 papers presented in 197 technical sessions, and a record number of 2,300 papers presented in interactive presentations. 24 GNFs, 18 special sessions, 13 plenaries, highlight lectures on very important topics, 3 late-breaking news events. We talked about Chang'e 6, Euclid, Ariane 6, and a highlight lecture on the Chandrayaan 3, which was fascinating, and a lesson in how to land on the moon, by the way, if anyone wants one. Really, our friends from ISRO could teach us some things. For the first time, we've gathered also more than 60 heads of space agencies and space offices in one place around a table to talk about sustainability. This was a truly historic gathering, never before happening, and I really appreciate the help of Ozzy in pulling this together. It was fantastic. The exhibition, if you could find the different levels and halls, of course it was massive. We had 500 exhibitors, 20,000 square meters of space. I got lost, just as you all did on the first couple of days, but once we figured out where everything was, it was really extraordinary, and we had amazing participation. The IAF has accepted now 72 organizations as new members from around the world, another record, by the way, including countries Armenia, Kazakhstan, Malta, Oman, and the Philippines coming into our family. So this is lovely as well. Look, we exceeded all of our expectations here. I knew the guys from AIDA and Ozzy and our co-host from Leonardo. We were all expecting a big event. You never know until we all show up in one place how it's going to go, but it's really exceeded our expectations. Everyone I've spoken with here seems like they had an amazing week, amazing connections that were made, so we appreciate you coming. This is what we do. This is why we come together, to push the boundaries and come together. Let me also take this opportunity to express my sincere thanks to the 3 outgoing vice presidents of the Bureau. Today we had, moving on, Lionel Souchet from CNES, Steve Eisenhart from Space Foundation, and Davide Petrillo from Voyager Space, who have been amazing contributors to us, and we really appreciate what they've done. Let me welcome them on stage. Please, guys, come on up. Your dedication is what makes this place run. Thank you so much. Okay, now we have 4 new incoming vice presidents that are joining us on the Bureau. Let me welcome them up as well. Amal Albinale, Samadin Azadov, Enrico Palermo, and David Spencer. Enrico, I think, is not with us. Yeah. And now joining us, Gabriela Arrigo from ASE. Please come up, Gabriela.
Picture with all our Bureau members. We are now moving on with the celebration of our amazing host, the Italian Association of Aeronautics and Astronautics, AIDA. Please welcome on stage my friend Professor Erasmo Carrera, Chair of the Local Organizing Committee and President of AIDA. Erasmo, please.
Hello, everyone. So my journey to this day started in Bremen a few years ago when we applied to host the IAC in Venice. Then we realized that Venice was probably, at that time, not the very most appropriate location to host this growing event. And in fact, it was, because the event is growing continuously. And then we applied to Milano. And then my final part of the journey started in Baku last year during this opening, this closing ceremony. You know, closing ceremony for me of IAC is the most significant moment because I see something magic in this room in the closing ceremony. Because we are on Friday, all the events I normally attend, in the last day there is no one. In the very last hours there is no one. So, and what is magic here? I see many, of course, young people. You know, 51% of the participants to this IAC were from under 35. So I think most are here, right? And what is emotional for me, really emotional, to see people coming from far to come to this event. Yeah, for most of the Europeans, it's normal to come to this event because we do this almost every time. But I know that in some countries it's more difficult because, as someone said in the assembly today, that the registration fee of IAC can be 4 to 10 times the salary for a month. So you can imagine how difficult it is. So this is something I feel in this room, that people from far and are here and they really put a lot of passion. So that's what is for me wonderful of this organization, this Congress. There are other things that have some interest, of course. You know, we plan to see Paris was a wonderful edition. Lionel did an extraordinary job there. They almost reached 10,000, and we say no one is going to pass this number in the future. And this was also for us very difficult to do, but we have worked in a unique way that AIDA knows, and also, of course, with the help of our cost, to be inclusive. Everyone that was proposing something to us to make IAC, we say, yes, we can do. Also in this position area, people were not allowed in the past to make some, to do something in there. Everything we have, I think there are people in this room that can really say that this was the case. So we were inclusive. We, of course, were a little bit disappointed when we got more than 7,000 abstracts, 7,500. And we know that usually the technical committee of IAF, they do accommodate a much smaller number of abstracts. So it was really disappointing because we said probably they will accommodate almost the same people that usual attendees, and then for the new one, there will be no space. Fortunately, we found a way to accommodate many of them in the IP sessions. IP sessions, as you have seen this time, have been held every day. So we accommodate about 2,000 IP, so we had the chance to increase a little bit the number. But to take care of the technical program for my side, you know, I'm a scientist mostly. I was somehow at AIDA for 7 years. I will stay there another year, and then, but I will leave and then to be full-time scientist once again. Things that I like to do. Study aerospace structures and do my best in that field. And so is, at the very end, by doing this work, Lionel, we were able to pass 10,000, which was, of course, not what we really want to do, but was, sometime aim and to work in that direction. I think this was the trick, to be inclusive. Yeah? And this was the result. And now it's a time for the, if I can pass a lesson to our friend from Australia, so to Lisa, Annie, and other colleagues from Australia, try to do the same. Try to do the same. Look at the program, what is happening here, and this position, and probably you will break another records, okay? You will go 50,000, probably. Okay, so it was really a pleasure for the AIDA and for the Italian Space Agency and for the Leonardo to organize this event. And another key point was that we have organized this event as a nation. ASI is the governmental institution, Leonardo is industry, and we had the pleasure to have in this place our president of the Italian Republic. That for Italian is something extremely significant. When he came, it was a great emotion for us all, and he gave a great honors to this. And this is a clear sign that he was a success of our nation, this event, for Italy, for Italia.
Thank you so much, Erasmo, and the whole AIDA team for the outstanding cooperation over the past few years. It has been quite a journey, but I think we can all agree that the results have surpassed anything we could have imagined. But let me now also acknowledge that the outstanding success of this IAC would not have been possible without the incredible support by our co-hosts and by our anchor sponsors. Let me express my sincere thanks to the Italian Space Agency, ASI, specifically to its president, Professor Diodoro Valenti, and his team. And to Leonardo, led by its CEO, Roberto Cingolani, and his team as well. And now, let us look back to this amazing week and watch a highlights video of this IAC 2024.
Ciao Milano. We're so happy to be here, and welcome to the 75th International Astronautical Congress, what is going to be the largest gathering of space professionals in history.
As you look to the stars tonight, know that we are waving back at you.
Congratulations, Gabriella Rigo.
Our mutual passion for astronautics inspires us to pursue solutions that enhance the sustainability and resilience of life here on planet Earth.
I think that this concept of sustainability is particularly important for women.
Let's work together to inspire the next generation .
The IAF is extremely proud to host this high-level gathering of senior leaders from global space agencies who joined us today to share their insights and visions for the future.
Mi piace moltissimo essere qui, nella Italia.
And now please welcome back on stage the IAF President Clay Mowry and Asandan Tisana, IAF Vice President for Honors and Awards and Chair of the IAF Honors and Awards Committee, to begin our traditional award ceremony.
Good afternoon, ladies and gentlemen. Dear IAF friends and family, in my capacity as IAF Vice President for Honors and Awards, it is my pleasure to present to you this year's IAF Awards. Several of these awards have already been awarded in the week. I'd like you all to join me as we acknowledge them once again. The 2024 IAF World Space Award has been bestowed to the Chandrayaan-3 team from the Indian Space Research Organization. The IAF Excellence in International Cooperation Award has recognized the long-standing efforts of Gabriela Arrigo, the Director of International Affairs at the Italian Space Agency, and Michael Gold, Chief Growth Officer at Redwire. The IAF Excellence in Industry Awards were presented to the United Launch Alliance and iSpace. The IAF Excellence in 3G Diversity Awards have been bestowed to the Common Project and the NASA Indigenous Community-Based Education Program. And our Interactive Presentation Awards were announced on Thursday. Let's please give them all a warm round of applause. Now, ladies and gentlemen, we need to turn our attention to the awards that are yet to be celebrated. And at this point, I would like to call upon David Spencer from the Space Education and Outreach Committee to stage to present the Frank J. Malina Astronautics Medal.
The Frank J. Malina Astronautics Medal commemorates the legacy of a pioneering rocket engineer and one of the founders of the International Academy of Astronautics. Today, we award this medal to an educator who has demonstrated excellence and outstanding commitment in promoting the study of astronautics and space-related sciences. We're delighted to present the 2024 Frank J. Malina Astronautics Medal to Professor Robert Twiggs, Emeritus Professor of Astronautics at Morehead State University. Unfortunately, Professor Twiggs could not be here with us today, but we are pleased to welcome on stage Professor Klaus Schilling to receive the award in his behalf. Professor Schilling.
Let us now move on to our next prestigious award, the Young Pioneer Award. It is my pleasure to welcome on stage Ozan Kara, member of the IAF Education and Outreach Technical Committee, who will present this award.
Thank you so much, Hasan, for introducing me to the stage. Dear IAF President Clay Mowry, IAF Secretariat, and all member organizations, and also AIDA President Erasmo Carrera on behalf of the local organizing committee. This week, we all share the excitement of the space exploration in different aspects. We followed the back-to-back meetings, presentations, plenaries, and we met friends we haven't seen for a long time in our space family. In addition, it was amazing to meet with new voices and share this excitement of the space exploration with next generations. And at this point of the adventure, I am very happy to present you IAC 2024 Young Pioneer Award. This award is presented each year to a young scientist below 30 years of age who has contributed significantly to the advancement of the aerospace science and has given a paper at the International Astronautical Congress. And first, I am delighted to call on the stage all finalists of the 2024 Young Pioneer Award, who are Alessandro Mignoni, Anna Humphreys, Claudio Tocchino Campana, Harry Shee, Mirko Bardin, and Ulubilge Ulusoy. I am delighted to announce the winner of the 2024 Young Pioneer Award is Mirko Bardin. Now we will have a group picture of the finalists and the winner.
I am now pleased to continue the ceremony by unveiling the new additions to the IAF Hall of Fame. The IAF Hall of Fame is intended to create a standing forum of personalities that have contributed significantly to the advancement of space science, technology, and space benefits to humanity. It is my pleasure to welcome on stage the first new member of the IAF Hall of Fame who has played a pivotal role in shaping the Hungarian space sector, Ivan Alma former president of the Hungarian Astronautical Society. Dr. Alma, please join us on stage.
Mr. President, ladies and gentlemen, I would like to thank this beautiful award because of its value, and I'm very proud that I have it on behalf of the Hungarian Astronautical Society. This is really an important award because I must say that it is for a lifetime work, and it is also a great honor to be among the many people who are belonging to the Hall of Fame of IAF, and therefore it is probably the highest prize I have ever received in my long life. Thank you very much.
Ladies and gentlemen, I am now pleased to call on stage the second winner of the IAF Hall of Fame, Edward Liu, former astronaut, executive director for B612 Asteroid Institute and CTO at Leo Labs. Please, Dr. Liu, join us on stage.
Thank you very much to the IAF and to the City of Milan for hosting us all here. It's an incredibly exciting time to be involved in space because the rate of change, of advancement is accelerating so fast. This year, on average, there are 10 satellites that are being launched every day this year. That's amazing. So near and dear to my heart, we're going to have some really big advancements coming up soon. In the fields of planetary defense. We're going to be finding millions of asteroids with the impending opening of the Vera Rubin telescope next year. For anybody involved in that, thank you very much, because that's how we'll protect the Earth from being hit by asteroids, because you have to find them and track them first. You know, with all these satellites going up, space situational awareness is becoming increasingly important, and there are huge advancements there, largely driven by commercial companies, actually. And finally, if I can make an observation, it is that, or a prediction, it's that I believe that one day there will be an IAC hosted somewhere other than planet Earth. And I hope that there are people in this audience who get to attend that someday. I say this because when asked to predict the future, most people overestimate the progress in the near term and underestimate the progress in the long term. So we'll see you all in space. Thank you very much.
Ladies and gentlemen, the third awardee of this category is a long-standing contributor to the growth of the whole space community, Maria Antonietta Terrino, Director of Space Economy, Exploration and International Network at Thales Alenia.
As you know, I didn't prepare anything. I wanted to speak from my heart, as I always do. I've been part of this family for more than 30 years, and I enjoy every single moment because I cross so many wonderful people. So for sure, this award means a lot to me, but much more than the award, I'm really moved for the many, 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 many messages that I received from many of you for the congratulations. Each of you added a color to this paper and into my heart. And I like to share the award with many of you. Thanks a lot.
I am now pleased to call back on stage a well-known friend of the Federation, Mr. Giorgio Saccoccia, the Senior Advisor to the Director General of ESA. Please join us, Giorgio.
Not easy to speak after Maria Antonietta, after Mimi. For me, receiving the award here in Milan has really a special meaning. Well, it's my 25th IAC in a row, quarter of a century. But also many of you, Clay, of course, Gabriella, Christian knows the personal effort I put a few years ago when I was president of the Italian Space Agency to bring this conference to Italy, to Milan. As Italian, I was sure it would have been a great success. So I'm really, really happy for that. I want to thank the Technical Committee of Propulsion, the Technical Committee of Space Transportation for having proposed me, and all the different organizations all over the world, the agencies, companies, institutions that endorsed with a supporting letter the proposal. But I want to really share this with all of my colleagues and friends from the IF community and family, the one that really share my passion for space that I had since I was really, really a child. And with all the young professionals, all the students that are sharing the passion and also facing a long future in this career. I can only wish them to have the same level of satisfaction, return, and fun that only this field can really give. You will really enjoy it, and I really tell you this with all my heart. So thank you very much.
We are now closing our celebration of the prestigious 2024 IAF Hall of Fame with the final personality. Please join me in congratulating Dr. S. Somathan, Chairman of the Indian Space Research Organization. And to receive this award, we'd like to call upon stage Dr. Kumar.
Good evening to all. Ladies and gentlemen, I am very happy and proud to receive this Hall of Fame award on behalf of Dr. S. Swaminath, Chairman, Indian Space Research Organization, who could not be here due to some emergent official activities at Delhi. And he has conveyed his appreciation to the excellent conduct of this IAC in Milano to the organizers of this IAC 2024. Also, he has conveyed his gratitude to IAF, its bureau, President Clay Mori, Executive Director Dr. Christian, and all others, all other IAF members for their support for ISRO and also giving him this Hall of Fame award. Thank you.
Thank you very much, Sander. We will now award prizes to the winners of the 2024 Young Professional Leaders, Young Space Leaders Recognition Program, It is my pleasure now to welcome on stage the outgoing Vice President for Education and Workforce Development, Davide Petrillo, to give these awards.
Christian, distinguished guests. The IAF Young Space Leader Awards recognize students and young professionals under the age of 35 who make significant contributions to astronautics through their work, engage with other young people in their communities to share knowledge and experiences and actively participate in IAF activities. We are very pleased to present the 2024 IAF Young Space Leaders Recognition Program winners and welcome on stage Aisha Alarham, Chief of Satellite Design Department from the National Space Agency. Please. Hamza Hamid, Senior Practice Manager, Space and Connectivity Access Partnership and former Chair of SGAC. Valentina Lucchetti, Sales and Business Development Representative, D-Cubed. Gina Petrovici, UN Affairs Department Legal Advisor of the German Aerospace Center. Carlos Rodriguez, Chief Executive Officer, Orbital Space Technologies. Takahiro Sasaki, Research and Development Directorate of JAXA. Please give them a huge round of applause that they deserve.
Congratulations and thank you all. I'm pleased now to share that the IAF has continuously intensified its efforts to supporting the younger generation, and we have increased notably the number of ESL grants over the past years. We are pleased to welcome them now on stage, and we really need a long stage for having all of them up here. Please welcome our 2024 IAF Emerging Space Leaders, and let me call them up one by one. Faye Abdul Ghani, Lily Rosbin Asongfak, Fanmita Atimolam, Beste Boibasi, Maria Paula Bustos Moreno, Jorge Ruben Casir Rezaño, Natasha Shamir Disha, Daisy Marie Domingo, Sariful Islam, Rebecca Jimenez Moya, Miroslava Kazluskaya, Sanat Kumar Naik Laxman, Tu Min Le, Stephanie Maria Leighton Ramirez, Yumna Mayed, Balagopal Manayil Santosh, Saktafong Mankaseum, Harry Stephen Mindarno, Edgar Mujuni, Stella Chelangat Mutai, Ruby Patterson, Anupam Kumar Pili, Shahade Fry, Prelefien Rai Kaur Rajavant Singh, Madiha Rashid, Samiksha Raviraya, Nishita Sangfi, Shreya Santra, Senor Shimhanda, Krishna Shrestha, and finally Matthew Derek Murray Sutcliffe. Please give them all a round of applause. Congratulations to all of them. What a lineup. I think in future we'll need a bigger stage even. Thank you. Thank you and congratulations. Now, thank you. Now, please kindly welcome on stage Professor Franco Bernelli. He's professor at the Politecnico di Milano, and he will present the winners of the 2024 IAF Student Competition Awards.
I guess this applause comes from my students that are here. So, as you might know, during the IAC, we have also a student competition where we have 3 different categories. We have competitive sessions where we spend our time grading students and their presentations. So basically this week, instead of grading students at my university, I came here to grade the students that were giving the presentations. We have 3 categories, I said. One is for undergraduate students, one is for graduate students, and one is for the best team of students. So I would like to call on stage the winners. Let's start with the undergraduate category. I would like to call on stage Mr. Madison Weeks from University of New South Wales in Australia. And the second prize of the undergraduate goes to Mr. Jared Orrick from the University of Manchester in the UK. Now, Jared is not here, so I would like to call on stage Simon Feast, CEO of the British Interplanetary Society, who did the selection of the students. So now we can move to the graduate category, where we have, we have also medals offered by Hermann Obert, offered by IFR. So the medals are in memory of Hermann Obert. So I would like first to call on stage Karl-Heinz Rohrwild for the delivery of the medals, and then the winners of the prize. So the first prize goes to Balagopal Anail Santosh, so back on stage again. And the second prize, Balagopal is from the University of Strathclyde in the UK. The second prize goes to Mrs. Ippolita Piacini from, unfortunately for you, Politecnico di Milano. And the last award goes to the team, student team project. So this prize is the Hans von Muldau Team Award. And the winner is Mr. Oscar Matias Hernandez Garcia from Universidad Nacional Autónoma de Mexico. And the cup is offered by DGLR. Just as a final comment, we have winners from 3 different continents. Next year, I would like to have 5 winners from 5 different continents. So please, I encourage all students to submit their best papers, because we are willing to work and grade them and have winners really from all the world, maybe even from Antarctica next time.
Once again, congratulations to all the awardees. Give them another round of applause, to all of them. Ladies and gentlemen, it is now time to acknowledge those people who have worked tirelessly over the past several years, I would say, on all the details of this Congress, program, logistics, exhibition, and so much more. Allow me to start with my fabulous IEF Secretariat team, and I would like to call them on stage here. Please, come on stage. Miriam, Isabella, Lena, Julia, Alessandra, she is sitting behind in the regie and make sure that all this, she's here, great, good. Evelina, Martin, Stefano, Constance, Svetlana, Sebastian, Michelle, Aaron, Victoria, Andrea, Anne-Sophie, Cyril, Pierre, and Mathieu. Please come up. And of course, the IAF president, please join the team here. Without them. And now, let me ask the chair of the local organizing committee, Professor Erasmo Carrera, to join me on stage to call up the local organizing team with whom we have worked so splendidly over the last years. Erasmo, please.
Yeah, so thank you, Christian. Your Victoria, she is well. Seems she is well. Okay. Thank you. So, I have to call on stage first the co-hosts. I don't know, Teodoro would like to come, please. Probably, I see that many from Leonardo, they left. Don't know if it's Marco or someone from Leonardo. I know that many left today, so probably there is no one. I also call from the AIDA side, the IPC co-chair Alfonso Pagani. Please, Alfonso. And the executive project director, Enrico Zappino, that has made many friends and some enemies by selling the booths. So also, of course, I know that you are now at a higher level, Gabriella, but you start to work with us on that years ago. Please come. I don't know if Anna Maria is here in the room. Anna Maria Monterisi. And sorry, because I know that people, Leonardo, they had to leave for some reasons. So there is no one, right? Roberto is not here. So, but we will represent, acknowledge to them. So, yeah. course, this event would not be possible with all the work done by other people that are not represented. But as President AIDA, I'd like to acknowledge the help for the students. We had about more than 200 students helping us during these 5 days. And also, I think, other people from AIDA and other from ASI and from Leonardo, which which are not on the stage. So we did a huge effort to get the results we have in this event here in Milano, that we know that we have broken any record. And so to do that, I thank you all of you that were helping. And of course, the wonderful team of IAF that just left the stage. It's really wonderful to work with them because they have a great experience and they really like to do everything in the best way, and this was really helpful for us. Okay, thank you once again.
Now, ladies and gentlemen, let us look a bit ahead, but before to immediately jump into IAC 2025 and switching to this next edition of the IAC in Sydney, let me draw your attention to a few important events which the IAF is organizing or co-organizing in the upcoming months. I think I have a slide here. Yes, you see it there. In December, we are co-organizing with the International Peace Alliance, the IP Space in Hainan. You find more information on our website. We will have our 2025 IAF Spring Meetings, 25th to 27th of March in Paris. And most importantly, we are having our next edition of a global conference, the Global Space Exploration Conference, GLEX 2025. And this is wrong, please, this is wrong. It is the 7th to the 9th of May 2029 in New Delhi, India. So, please. And then, of course, after this, we finally will meet again at the IAC 2025, which will be hosted next year in the beautiful city of Sydney in Australia. And I would like now to welcome the team on stage. Jeremy Hollett, Executive Chair of the Space Industry Association of Australia, and Lisa Vitaris, Director, IAC Sydney 2025, to sign the IAF final contract for hosting the IAC 2025. And now it's time to do our traditional flag handover. And for this one, I would like to ask you to remove the table again to have a clear view. And let me call on stage for this again Professor Erasmo Carrera, Chairman of the IAC 2024 Local Organizing Committee, and his colleagues, Professor Alfonso Pagani and Professor Enrico Zappino.
G'day everyone. Thank you to Clay and Christian from the IAF. My name is Jeremy Hallett and I'm the Chairman at the Space Industry Association of Australia, the peak body for space in Australia. And we are the host of IAC in Sydney in 2025, alongside our co-hosts, the Australian Space Agency and the New South Wales Government. I'd like to thank our hosts this year, Erasmo, Alfonso, Enrico from AIDA, for a beautiful IAC here in Milan. And as we reflect on what an amazing week this has been, I'm pleased to offer you a warm welcome to Sydney for IAC next year from the 29th of September to the 3rd of October 2025. And remember those dates. It's going to be held at Sydney's impressive International Convention Centre, located right on the water in Sydney's beautiful Darling Harbour. We'll be exploring a theme of sustainable space, resilient Earth, which is looking at three elements: the use of space capability for a sustainable and resilient future here on Earth, the sustainable use of space, and thinking about humanity amongst the stars, how we sustain life off Earth. And of course, we look forward to showcasing the rapid growth in the space sector in Australia since we last hosted IAC in 2017. But Sydney is a global city. And during the Congress in Sydney, we'll be highlighting the whole of the Indo-Pacific space sector, with expectations of significant contributions of not just Australia, but India and China and Japan and South Korea, Thailand, Malaysia, New Zealand, and many others all through Southeast Asia and the South Pacific. And in exploring our theme, we are making a concerted and organised effort to bring space-enabled sectors into the fabric of IAC, including sectors such as agriculture, resources, emergency management, smart cities and telecommunications. And finally, in addition to all things space, we know that Sydney and Australia is, I think, probably the #1 destination for most of you. And so when we welcome you to our country next year, we'll have amazing opportunities to explore our culture, especially that of our First Nations peoples who have the world's oldest continuous culture stretching back over 60,000 years. You'll get to see the sights of Sydney, including our amazing Sydney Harbour Bridge and the Sydney Opera House, and our famous natural beauty, including our animals that we know you love, such as our koalas and our kangaroos. So please go to the Congress website at iac2025.org to register your interest and receive updates. Sponsorship and exhibition is open for booking through the website now. The call for abstracts will be opening next month, and registrations will be open early in the new year. Looking forward to seeing you all in Sydney. Thank you.
The space sector is astronauts and rockets, but more importantly, it plays a crucial role in our lives through telecommunications and Earth observation, as well as satellite technology's use in daily applications such as weather forecasting, GPS navigation, and global communication systems. Space exploration not only pushes the boundaries of human ingenuity and exploration, it is now increasingly critical to life on Earth. With its rich history of space exploration and environmental advantage, Australia is the perfect place to explore the next phase of growth in the global space sector. That's why Australia is the perfect host for the 76th International Astronautical Congress, which will take place in Sydney, with a theme of sustainable space, resilient Earth.
Australia is an ancient country, and a new one. Since time immemorial, First Nations Australians have been studying the skies, mapping their meaning and developing deep knowledge about their patterns and impact. Our skies are the biggest, our knowledge the oldest, and our region the boldest. Today, Australia has over 600 organisations operating in the space sector, and our Indo-Pacific region and country partners are home to extraordinary opportunity for space. Ancient and extraordinary landscapes, a unique geographic spatial position, and a wealth of investment in space-based technology has allowed Australia to innovate across industries. from emergency services, health, utilities, and telecommunications to resources, manufacturing, and agriculture.
Join us from the 29th of September to the 3rd of October in Sydney, Australia. To learn more about these innovations, make meaningful connections, connect with the ancient and the new, and explore partnerships with others in the industry. Collaboration can make the impossible possible. See you at IAC Sydney 2025.
Thank you to Jeremy and Lisa. This looks really stunning. I can't wait to go back and visit Australia again and see you all again at the IAC in 2025. We've kept you here long enough. Just a quick housekeeping. We have the gala event that will take place at 7:30 in the Gold Hall here. So hopefully many of you are coming back for that event or staying for that event and just getting a bit freshened up. Really, we've had an amazing, amazing time. I thank you for all coming. And just let me finish by saying, ciao Milano, good day Sydney.